Okay, this lesson is 8-4, area of composite figures. So to find the area of a composite figure, you need to separate it into figures with areas you know how to find. So you're going to be looking at the area formula for several different two-dimensional figures. A composite figure is a 2D shape that is made up of two or more other shapes. That is a composite figure. Okay? So we're going to be finding areas of figures, two-dimensional figures that are strange in shape. So if you look at this first example, your book does a nice job of showing you that area is essentially how many of those squares a figure can take up. So you can use that to calculate area. So if you look at this, at the second row, so when you have a composite figure like this, what you want to do is you want to count the number of squares that lie entirely in the figure. And if you do that, there are 45 of them. And then you're going to count the number of half squares in that figure. And if you see that, there are 5 of those. So if you match up every half square as 1, that's 1, that's 1, so it's 2.5. So you're going to take your 45 and you're going to add that to your 2.5, which then will give you 47.5 square units. So that's how you do these types of problems. So what I'd like you to do is pause your computer, and I'd like you to do number 1. Okay? Pause your computer and do number 1 and then come back. Okay, so for number 1, what I would do is I would count every single one of these whole dots, or whole squares, okay? Then you have these at the side here that are partial. And actually, if you look at it, this one matches this one. This one right here matches this one right here. And they match up back and forth, back and forth, back and forth. So if you do that, you'll see that you have 37 square units. Okay, I counted here, and then I tally this, and you end up with 37. Okay, if you got that right, you can move on. If not, you should rewatch so you understand how to do that. Okay, the main way to find area of an irregular figure, a composite figure, they used to be called irregular figures years ago, is to find the area of the portion using shapes that you know, okay? So you want to find the area of this, the key, this is called, of a basketball court, okay? So this is your free throw lane, and then your jumping circle, which is your key, the top of the key. So what you're going to do is you're going to find the area of the rectangle and then the area of a semicircle, because this part of the circle, this is included in your rectangle. So you're not going to include that in your area, or you'd be doubling it up. So you really only need the area of this portion of that circle, which is a semicircle. So the area of your rectangle is length times width, and the area formula to find a semicircle is area equals pi r squared divided by 2. We're dividing it by 2 because the figure that you need is just a semicircle, half of a circle. So what you do is you find the area of your rectangle, which is 228, and then you find your area of your semicircle, which is 56.57, or 52, sorry, and then you add those together, so your total area of your shape is 284.52 feet squared. Okay, so you find the area of the rectangle, the area of the semicircle separately, and then add them together to get the area of your composite figure. Okay, so this is an example of something that you might see. Now this, if you kind of have to break it apart. There's a triangle here, then there's a rectangle here, and then this shape is a parallelogram. And the area of to find the area of a parallelogram, it's the same as area of a square or a rectangle. Its area equals base times height, but that height has to be this perpendicular line, the 90-degree angle. You're looking for that red box. So you find the area of your triangle, your area of your rectangle, and your area of your parallelogram. The area of the triangle is, the formula is 1/2 base times height, so that comes out to 25.2. The area of the rectangle is base times height, or length times width, that comes up to 36. And the area of the parallelogram is also base times height, and that's 8 times 6.7, which is 53.6. So then you add all three of those numbers together, all three of those areas together, and you get 114.8 square centimeters. Okay, so what I'd like you to do now is I'd like you to try on your own number 3. Try number 3 on your own. Okay, so this is area of a rectangle, so it's base times height. This portion right here is a rectangle, base times height. Then it's area of a triangle, which is 1/2 base times height, or base times height divided by 2. So your rectangle is 9 times 7, because it's a base of 9 and a height of 7. 9 times 7 is 63. Your area of your triangle is 9 times 6. Your base here is the same as this one, so 9 times a height of 6, but you have to divide that by 2. And you end up then with 54 divided by 2, which is 27. So you take 63 plus 27 to get your area of your figure, and that is 90 meters squared. Okay? Okay, so what I'd like you to do is I would like you to complete problem 3 and problem 9 for me for tomorrow. Problem 3 and problem 9. Okay?